Good day all. Today we will be looking at another question on DC machine. Our question says a 25 kilowatt 250 volt DC machine is shown below. The field current is held constant and the speed is 3000 RPM. The open circuit voltage is 250 volts. Calculate 1. Terminal power. 2. Electromagnetic power. 3. The torque at a terminal voltage of 255 volts, 248 volts if the armature resistance is 0.05 ohms. Now, for us to be able to solve this question, we need to understand what this phrase open circuit means. Now, in an open circuit is that which doesn't have a complete closed loop or path. A circuit that doesn't have a complete closed loop. So let's say this is our battery and it is connected to, let's say, a resistance in series, and there is nothing connected at this point. And let us give our voltage to be what? 20 volts. So we can then say that there is a voltage at the terminal. We can still call it what? VT. And we can give our resistance, let's say 5 ohms. Now, one thing with an open circuit is that current doesn't flow through it. For current to flow, this path has to be completed. It has to be complete. It has to be joining. But since it is open circuit, it will not allow the flow of current. So in our short circuit, we know that what current is what? Zero. Another thing that we also need to know is that the current, the voltage at this point, which is our VT, is equal to the voltage of the battery. That's another thing that we need to know. The voltage, if you bring your multimeter and you measure it at this point, though it will complete the circuit. Your multimeter will complete the circuit, but if this resistance wasn't here, your voltage will be your multimeter will tell you that the voltage at this terminal is 20, and hence since there is no current, there is no voltage drop across the resistance, because for voltage to drop across the resistance, there has to be a current that to satisfy this rule. So there will be no voltage drop here, and VT will be equal to the battery's voltage, which is 20 volts. So I wanted us to know this about a open circuit, because we are given an open circuit voltage. Now this open circuit voltage, what this tells us is that our VT at this point is 250, but since it is open circuited, no current is flowing through this circuit when VT is 250, and E, which is the armature EMF, is also 250 since it's a what? An open circuit. So knowing this, we will then say that in open circuits, IA is what? 0. This is our mature current is 0, and our E, whether you choose to call it B or G, depending on whether it's a motor or generator, but here we aren't told. So we can just assume a particular E to give to it, but it's still an EMF. So the EMF, this E, is equal to Vt. Because of what? It is a open circuit voltage. So if we know this about this, the question is now demanding us to get the terminal power, the magnetic power, torque at a terminal voltage of this. Now, our terminal voltage is now what? Changing. Another parameter that they gave us here is the armature resistance. So let me just add it here, 0.05. So our terminal voltage now is what? Changing. Previously, they gave it to us when there was no current flowing in this circuit, but now current is flowing now. Current is flowing because they didn't use open circuit again, but terminal what? Voltage. So using this, we are meant to find our armature current, but from the whole story, what we are able to get is that the actual value of the EB generated or the back EMF is what? 250. So we can then say that the value here is what? 250. This is the one that didn't change. EB is equals to what? 250. But VT is now changing to 255. Now, before we go further, we like to revisit the equations of both a DC generator and a DC motor. A DC generator has this formula to be: a generator converts mechanical to what? Electrical. So it is the armature that is supplying current to the terminals. So we have that our generated EMF minus our resistance, our voltage drop due to the armature resistance, those two we equate to what? Vt. We can still rewrite this to be Eg is equal to Vt plus I A R A. Now for that of the motor, motor converts electrical to mechanical. So our general voltage will be gotten from the terminal Vt, and this Vt we equate to both your back EMF and your voltage drop due to the armature resistance. So we have this formula and this formula for generator and for motor. So looking at this equation, logically we can say that Eg will be greater than Vt in this case. Eg will be greater than what? Vt in this case, because whatever Vt is, you have to still add the voltage drop due to the armature resistance to get what Eg is. So we can conclude here logically that Eg is what greater than Vt for this. Now coming over to this, our Vt, we can say again, our Vt is greater than what? Our Vb, because whatever Eb is, we have to still add the voltage drop due to the armature resistance to get what our Vt is. So over here we have that what? Vt is what? Greater than what? Eb. So that's the difference between another difference between the generator and the motor is that for the generator, the generated EMF is greater than the terminal voltage. But for the motor, the terminal voltage is greater than the back EMF. Now, knowing this will help us to determine what equation we'll be using for this. So, like we said earlier, EB is equal to what? Vt. And we are giving this to be what? Initially to be what? 250 what? Volts. Open circuit voltage. We're giving it to be what? 250 volts. Now we have our EB. We have our EB or E, whatever you choose to call it, to be what? 250. Now they're not asking us to find terminal power, electromagnetic power and torque at a terminal voltage. Now the value now that is now changing is what? Vt. Vt is what is now changing. While here Eb and Vt was equal when I was equal to what? 0. But at this point now, one of them is what? And Vt is now being what? Changing. It's no longer the same. So this will help us determine, using both this ideology we have gotten from this generator and motor formulas, we can use it now to determine whether this or this is either for a motor or for a generator. Now I will clean this part to create room for us. Okay, so remember, let me just write it by the side. For a gen, Eg is what? And for a motor, Eb is less than Vt. Now, okay, so looking at this terminal voltage given to us, we are told that Vt is now what? 255. But our E still remains what? 250. Now, knowing this, between the two, which one is greater? The Vt. And when Vt is greater than Eb, we call the DC machine a what? A motor. So we'll be using that of a motor, the motor's equation, to get our Ia here, because we need to get our Ia in order to get both this terminal power, electromagnetic power, torque. The three of them, we need our armature current. Now, for the equation for a motor is Vt is equal to E. So in this case, we can call this Eb. Eb plus Ia Ra. Making isolate of formula, we have that Ia Ra, this will remain, while this will move over, and we are having what? Vt minus Eb. Now, taking this guys out of formula, we have Ia is equal to Vt minus Eb. all over RO A. So this is the formula we'll be using. Now, imputing our values, we have that VT being what? 255. We subtract itself from EB, which is 250. And divided by what? Our armature resistance, which is 0.05. So with a calculator, you impute that. 255 minus 250, 0.05. The value it gives is what? 100. So our armature current for VT equal to 255 is what? 100. So let's make a sign here. This is 100 ampere for what? IA. Now for the second one, here we can see that VT is now less than what? E. So we'll be using the generator's what? Equation. So here we have 2, 4, 8. Okay. So using the generator's equation, we have EG is equal to VC plus IARA. Taking this guy over, we have IARA is equal to EG minus VC. Dividing by our RA, we have that IA is equal to EG minus VC all over RA. Imputing our values, we have EG being 250. We subtract itself from 248 divided by 0.05. And when you do that, you will get 40. So for this, we have that our armature current is what? 40 ampere. So for each condition, our armature current differs. So now we have gotten our armature current. We can now get our terminal power. Our terminal power, which is our input power, is equal to VT times what? IA. And we are going to get it for the two cases. So for where IA is okay, for the first one, which is our A, we have that VT is what? We have that P in is VT is 255 and our I is what? 100. Multiplying this, we have that 255 times 100 equal to so we have 25500 in what? Watts. Converting this, you can still say 1, 2, 3, which is what? 25.5 kilowatts. Now, for our B part, our Pin for our B part, which is this, we have gotten the two values we need already, so we'll just impute it there. We are having 248 times 40, and this will give us 9920. Converting this, we have 1, 2, 3. This is equal to, in watts, this is equal to 9.92 kilowatts. So we just found the terminal power when the terminal voltage is both this and this. This is what we have gotten as our answer. Now for us to find electromagnetic power when this is this and this is this, our formula changes. Our formula, since, and this will be output now. This is our out power. This will be E B or EG times IA. Now for our A, this will EB is what? 250. This is our what? Our EB. Now this multiply by our armature current for the first one, which is 100. This will give us 25000 in what? Watts. Converting, we have that this is 25 kilowatts. For B part, we have our P out, 248 times, 250. It is not 248. 248 is VT. These two values are for VT. Our EB is 250. So 250 times 40 is equal to, okay, this times this is 100, then the extra zeros. So I guess it's going to be this, but let me still confirm. Okay, I'm correct. So converting this to kilo, you have that 10 kilowatts. We have this to be what? 10 kilowatts. So these are the values of our electromagnetic power for both cases, for case A and case B. We have gotten this. Now we will be looking for the final boss, which is the torque. The what? The torque. Now, like we said earlier, torque, okay, we have that P out is also equal to your torque times your what? Angular speed. Your angular speed is equal to 2 pi over 60 times n. This is also speed, but this is measured in revolution per minute. Revolution per minute. That is the SI unit for this N. But this over here is measured in rad per seconds. So they are not, though they are both speed, but they have different units. They have different units. So knowing this, we can get our W. We have previously gotten our P out for each cases, but since we have cleaned it, we can still equate this to be our E B I A is equal to T W. Okay, now for us to get our W and then make this sort of formula, we have we input our values, which is 2 pi over 60. This will be multiplied by our 3000, which was the speed given to us. This cancels out this. 6 here is 1, 6 in 30 is 5. So we'll be having 2 pi into 50, and to give us approximately 314.16 in watts rad per seconds. Now, knowing this, we have gotten our W to be that. So you can say can still clean this. So this is the value of our W. Now making C sort of formula over here, we have that T will be equal to E B I A over W. For the first case, that's the one that gave us IA to be 0. So we have, for the first case, T is equal to EB being what? 250 times what? IA being what? 100 will be divided by what? Our 314.16. Imputing this in a calculator, we have approximately 79.58 Newton meter. That's for the first case. Now for the second case, let's write this over here. We have that our words W is 314.16 rad per seconds. Now for our second case, that is terminal voltage being this and armature current being this, we have that T is equal to EB being 250 times IA being what? 40 this time around, divided by our W, which is this. Now imputing this in your calculator, you have your answer to be 31.83 Newton meter. So this is the value of our torque for case 1, this, and for our torque in what? Case 2. So we are gotten total of 6 answers, 2 for each of them in this question. Thank you and God bless you. We'll meet in the next video. Please subscribe. God bless.